So let's discuss what is meant by impulse. The effectiveness of a force in producing motion or change in motion depends not only upon the magnitude of force but also on the time for which the force acts. This is very evident from our daily life situations also. But there are many forces which acts for a very short interval of time, but the effect caused by them will be very large. I will say some examples. When we hammer a nail, that means you will be keeping the nail on the wall and using the hammer you will be applying force on the nail. So the force exerted by the hammer on the nail, it acts for a very short interval of time. Okay, but the effect produced by that force is very big. That means that nail, it pierces into the wall. You may not be able to measure the force exerted by the hammer, or you may not be able to measure the time for which the force acts. But there is a change in momentum for the wall and for the nail. So this is what we mean by impulsive forces. Impulsive forces means a large force which acts for a short interval of time. Another example of impulsive force is the force exerted by the bat on the ball during the cricket play. Or when we kick the football, the force exerted by the leg on the ball. All these are examples of impulsive force because we may not be able to measure the force, but there is an effect of the force and the time also is not measurable. In case of such forces, that means impulsive forces, the effect of that force can be expressed in terms of a quantity called impulse. So impulse is defined as the product of force and time interval. The magnitude, the product of force and time interval gives you the impulse. So from Newton's second law of motion, we know F is equal to delta P by delta T. F is equal to delta P by delta T, where delta P is the change in momentum and delta T is the time in which that change in momentum takes place. So what about the product of force and the time duration? Force and time duration, that product F into delta T gives you delta P. So this F into delta T is defined as the impulse, and impulse is equal to what? Change in momentum. So this is how we measure the effect of a force which acts for a short interval of time in terms of impulse. So impulse is nothing but the product of force and time, and that is equal to the change in momentum. So naturally the impulse is measured as the change in momentum, and it has the unit as the same as that of momentum. Impulse has the same unit, SI unit, and as that of the momentum. And its dimensional formula is ml t raised to minus 1. So impulse is nothing but the product of force and time interval, and it is equal to the change in momentum. So that is about impulse. Now coming to the law of conservation of linear momentum. Actually, Newton's second law and third law leads to this law of conservation of linear momentum. So what is this law of conservation of linear momentum? The statement of law of conservation of momentum, it goes like this. The total momentum of an isolated system of particles is conserved. What we mean by isolated system of particles? Let's discuss what is meant by system of particles. System of particles or system of objects means it's a collection of two or more objects. For example, when we consider the event firing of bullet, bullet is fired from a gun. So that system consists of gun and bullet. So it constitutes a system. When two objects collide, an object is colliding with another object, there are two objects. So those two objects together constitute a system. So that's what we mean by a system. That means a system, it consists of a collection of two or more interacting particles. They interact with each other. So that's what we mean by system. What do you mean by isolated system? Isolated system means the system on which no external force acts. external force acting on the system, if it is 0, we can call that system as an isolated system. External force only is 0, but there can be internal forces. That means within the system itself, two objects, if you are considering a system of two objects, object A can exert a force on B and B can exert a force on A. So that comes as internal force. So internal forces can be there, but for a total momentum to be conserved, the condition is this: external force acting on the system should be 0. So if the external force acting on the system is 0, the total momentum of the system will be conserved. This directly follows from second law of motion, Newton's second law of motion. We know according to second law, as we stated earlier, F is equal to delta P by delta T, where delta P is the change in momentum and delta T is the time we said. And what is F? The external force acting on the object. F is defined as the external force. So if F is equal to 0, if no external force is acting on the system, we know F will be equal to 0. If F is equal to 0, what does it imply? Delta P by delta T equal to 0. Delta P by delta T equal to 0 implies what? Delta P is equal to 0. So if F is equal to 0, it gives the result delta P equal to 0. What is delta P? Delta P is the change in momentum. What do we mean by stating that change in momentum is 0? Change in momentum equal to 0 means momentum is constant. So this implies P equal to a constant. So this is how we get this law of conservation of momentum from the second law of motion. So from the second law of motion directly we get law of conservation of momentum. So once again, the statement of law of conservation of momentum, it's very simple. Total momentum of an isolated system of particles is conserved. Your system means collection of two or more objects, and isolated system means the external force acting on the system is 0. So that's what law of conservation of linear momentum.